And now it is really my honor and privilege to introduce our next presenter, Dr. Katherine Calvin, who is a chief scientist and senior climate advisor. She's a trailblazer and first person who combines both of those very important roles at NASA. And as you can see from this profile, as NASA's senior climate advisor, she provides insights and recommendations for NASA's climate-related science, technology, and infrastructure program. And as a chief scientist, advises agency leadership on the agency's science programs and science-related strategic planning and investment. And one of her goals is to connect NASA scientists with other scientists and communicate climate science to other agencies and the public. Since 2008, Dr. Calvin has been an Earth scientist at the Pacific Northwest National Laboratory's Joint Global Change Research Institute, where she worked on global change analysis model, a system for exploring and analyzing the relationships between human and Earth systems in the context of global climate change. She has a Bachelor of Science degree in computer science and mathematics from University of Maryland, and received her doctorate in management science and engineering from Stanford University. She authored over 100 publications, and some of the recent ones have investigated growing populations against agriculture and water scarcity in the face of climate change. She's incredibly busy, and we are so happy that she was able to find the time to join the Space Apps Global winners, our local leads, our ambassadors, our SMEs to be with us today and share some exciting things that are happening across NASA. And as with previous presentations, we very much encourage you to write the questions that come up in the chat, and we'll be able to address them after the presentation. So Dr. Kate, thank you so very much for being here, and I'll just pass the floor to you, and we'll start your presentation momentarily.
Yeah, thank you so much for having me. I'm really excited to be here. I had the opportunity to watch the Global Winners video that was just played and hear about your creative solutions, and I'm really inspired by what you've all done. Congratulations to the winners on all of your hard work and well-deserved recognition. I did just want to note, of the 4,500 teams that participated in the hackathon, only 10 teams were selected to win. That's really similar to our latest astronaut recruitment, where NASA selected 10 astronauts of the 12,000 that applied. So just like the astronaut recruits, you faced challenging odds and rose to the top. I've looked at the agenda and seen what you guys have been doing this week. And so I see earlier today you had a chance to brainstorm ways to keep developing your projects. Others had the opportunity to learn about different pathways towards careers in science and technology. Whatever path you chose, we at NASA are going to be wishing you well and wish you the best in your future endeavors. So what I want to do today in my presentation, as was mentioned, I serve in a dual role of chief scientist and senior climate advisor. So I want to give you a little bit of a window onto both aspects of that at NASA. So tell you a little bit about climate and a little bit about the rest of the science portfolio. So I just wanted to start before I go into this about why, and just answer the question, why climate? So why are we talking about climate at NASA? And well, the reason is that we know from observations made on and above the Earth's surface that the planet's climate has changed. This animation is showing changes in temperature. It started in the 1800s, and it's going to animate its way through to today. And what we can see from this is that temperatures are rising. 2021 was tied for the 6th warmest year on record. Collectively, the last 8 years have been the warmest since modern record keeping began. And we're not just seeing increases in temperature, we're seeing other changes in the Earth system that go along with those increases in temperature. So we see declines in Arctic sea ice, increases in sea level. We see changes in extreme events, so more heavy precipitation events, more droughts, more wildfires, and more heat waves that come along with this. What we know from science is that many of those impacts are going to increase as temperatures rise. So we'll continue to see more of those changes if temperatures continue to increase, as they have been in the past. We also know that some of those changes are irreversible. So things like ice sheet melt and sea level rise can't be reversed on hundreds to centuries or centuries to millennia long timescales. We also know from science what's driving these changes. So it's unequivocal that the increases in temperatures that we've experienced to date are driven by emissions from human activity, and in particular, greenhouse gas emissions. We also know that future warming depends on future emissions. So we have quite a bit of understanding about the climate, and we're experiencing impacts from that today. Okay, so I wanted to give an overview of what NASA is doing with respect to climate. And I know you've already heard from Karen St. Germain, who would talk about what's going on in the Earth Sciences division. So I'll touch on those parts of our climate portfolio briefly, but we have climate research going on throughout the agency, beyond just the Earth Sciences division. So I wanted to give a little bit of an overview of all of that. So first, we're the US space agency that provides end-to-end research about our home planet. This includes observations, models, applied sciences, and technology development. For observations, we have more than 24 satellites and instruments in orbit, including several on the International Space Station. We use our unique vantage point of space to see the Earth, and we can see things like vegetation, clouds and precipitation, carbon dioxide, changes in the mass of ice sheet, and much more. And we've been observing the Earth for decades, so we can see not just the state of the Earth today, but also how it's changed over time. Just as one example there, the Landsat satellites, we've just launched Landsat 9 in September, and we're coming up on 50 years of Landsat data. So we have 50 years of observations. And what this satellite shows us is land use and land cover. So we can see where there are trees, we can see where there's urban areas, we can see ice and snow and crops. And since we've been observing this and capturing this information for nearly 50 years, we can see how that's changed over time. And when you look through those records, what you see is expansions in urban areas, declines in forest in some parts of the world. And these are really important for climate, as the land both absorbs carbon, releases carbon, so it affects the amount of carbon dioxide in the atmosphere. It also reflects and absorbs sunlight, so it affects the amount of heat exchanged between the atmosphere and the Earth's surface. So understanding how land use has changed is really important. And we have a number of satellites that look at different aspects of the Earth, and we have a bunch of missions coming up, which I'm sure Karen mentioned to you. In addition to our Earth observations, we also develop technologies that can help us mitigate or adapt to climate change, like sustainable aviation technologies. Our aeronautics team has worked with the aviation industry for a while to help reduce energy use and emissions in aircraft. And they have a lot of ongoing research related to things like aircraft design, air traffic management, airline operations, and sustainable fuels that have the potential to reduce emissions further in the future. We provide information throughout our climate research efforts to aid in disaster response and inform planning. So with disaster response, we work with local responders and governments before, during, and after a disaster occurs to provide near real-time Earth observations and applied science information. For planning, we have climate models that both help us understand the world today and how we got here, but also give us a way of looking into the future and seeing how climate might change, which is really important for long-term planning. Throughout all of our portfolio, we're working to make climate change data more accessible for researchers, planners, and individuals in vulnerable communities. So we already make all of our observation data freely available to the public, but we're working to go beyond that and make sure that people have the resources and tools they need to make informed decisions. That means including not just data, but also the tools that we use and make those available, and also making things in easier to use formats like cloud compatible data. The last part I want to mention about climate change is, in addition to doing research on climate change, we're also impacted by climate change. We have several facilities that are in low-lying or coastal regions, and they're vulnerable to things like sea level rise, storm surge, and hurricanes. We have centers in California that are vulnerable to wildfire and drought. So we have climate efforts going on throughout NASA. But I also want to talk about the rest of the science portfolio. So if you go to the next slide, I'm just going to provide a few highlights of other really exciting science missions coming up. So first, I wanted to talk about planetary defense. So we have a planetary defense coordination office, which is tasked with finding near-Earth objects, tracking where they're going, coordinating with other federal agencies, and thinking about mitigation strategies. And one of the spacecraft that we launched last year in 2021 is a planetary defense mission. This is called DART. DART is going to test whether or not we can impact an asteroid with a spacecraft and change its orbit. So if we hit it, will it move enough? And that's what we're really testing here with DART. The spacecraft launched last fall, and the plan for the impact is this fall. And so we're looking forward to that and learning more about planetary defense in the process. We also explore other planets, and a lot of what we learn there can help us understand our solar system and our home planet. So all of the planets in our solar system form from the same cloud of gas and dust about 4.5 billion years ago, but all the planets look really different now. Mars and Venus were both once thought to have liquid water, but they've undergone some pretty extreme climate changes and aren't thought to be able to support life now. So Mars is now really cold and dry, and we don't totally understand what has caused the climate changes that we've experienced on Mars. This figure is showing Perseverance and Ingenuity, a rover and a helicopter that are currently working together to explore the Martian terrain. They're taking images and collecting samples and trying to understand what we can learn about Mars. And the hope is that what we learn about Mars might give us some information and insight into Earth. We've had similar experiences looking at other planets. So Venus has also undergone some pretty extreme climate changes, and it's now really, really hot with a really high concentration of carbon dioxide in its atmosphere. Some of the research on Venus done decades ago on greenhouse gases and ozone has informed our understanding of greenhouse gases and ozone on Earth. On Earth, there's very different drivers. So the greenhouse effect and ozone depletion that's happened on Earth are driven by human activities and emissions from those human activities. But the processes are the same. And so what we learn about Mars from our orbiters and rovers may provide insight into Earth, and it'll definitely provide insight into the evolution of our solar system. So another mission that I'm really excited about is the James Webb Space Telescope. I'm sure if you've been following online, you've seen lots of information about this. This telescope was launched in December, and we're expecting the first science images from it this summer. The telescope lets us look back in time 13.5 billion years to see the formation of some of the early galaxies in our universe. We'll be able to see the evolution of those galaxies. We'll also be able to look at atmospheres of exoplanets, and in some cases get a sense of the temperature of those exoplanets. So the James Webb Space Telescope will give us a picture over time of a lot of the astronomical phenomena that have occurred and changed. And it's really interesting and exciting to me that we can look back so far in time with a telescope like this. The two images I'm showing here, one are a drawing of the space telescope, another is a picture from its alignment image. So the spacecraft, it launched in December, and we get the first science images this summer. In that period in between launch and science images, it's traveled out to 1 million miles away and undergone an alignment and calibration and cool down process so that it's ready to do science. I'm looking forward to seeing what it brings this summer. So the last thing I really want to touch on is Artemis. So Artemis is a series of increasingly complex missions using humans and robots to explore the moon in preparation for missions to Mars. The moon and Mars and Earth, they're the three planetary bodies we know the most about. So the more we learn about them, the more we can understand the evolution of planets in our solar system. This first mission in the Artemis program is Artemis 1, which is targeted for launch this year. And what you're seeing here is an image of Artemis 1. So this is the SLS rocket and the Orion spacecraft on top. And they're this is a picture from the launch pad at Kennedy Space Center during wet dress rehearsal. And so you can see the image of the rocket out there now. The rocket will launch later this year. And the idea in Artemis 1, it's an uncrewed mission that'll let us test the new rocket and spacecraft. This is the first time flying that. So we'll get some experience with that before we put crew on it in Artemis 2. We're also going to learn a lot about moving outside of low Earth orbit. So when you get outside of low Earth orbit, there are different requirements. There's higher radiation, which has impacts on crew and electronics. And so we'll learn quite a bit about that in Artemis 1. There are a bunch of science payloads on Artemis 1, including 10 CubeSats. And those will help us both understand radiation, but there's also some CubeSats that'll give us more information about the lunar surface. And so we can learn more about what's going on the moon through the Artemis 1 program. There's a series of these missions. So Artemis 1 is uncrewed. Artemis 2 will include crew. Artemis 3 will put people on the surface of the moon. And throughout the Artemis program, we're going to be putting the first woman and the first person of color on the surface of the moon, which is really exciting. So keep a lookout for that going forward. Again, Artemis 1 will be launching this year, and we'll be able to track its progress through social media and NASA and our normal outlets for watching. So I think this is my last content slide, but I did want to just conclude by giving some highlights of where we're going, since I covered everything really briefly today. So first, going back to climate, we have a lot of upcoming missions in 2022, and just highlight a few. So one is we have emissions that are going to help us better understand tropical cyclones and mineral dust and surface waters. All of these have different roles in climate change. So for mineral dust, this is substances that can reflect or absorb sunlight, and that affects the amount of heat that the earth absorbs. They also have implications, mineral dust has implications for air quality, which impacts humans' health and ecosystems. The surface waters have a really important role both in human activity and in climate change. So we have a mission called SWAT launching in November that'll provide the first global survey of the amount of water running through rivers and lakes. We use water as we're growing crops and producing energy and in all of our daily activities. And so understanding how much water we have available is really important for understanding the evolution of those activities, both in the past and in the future. SWAT is also going to give us a better sense of oceans and their role in climate change. Oceans absorb a lot of heat and carbon right now, and their ability to continue absorbing heat and carbon influences the amount of warming that we'll see going forward. I mentioned a bunch of our non-climate science missions going through. So we're looking forward to DART and James Webb Space Telescope and Artemis coming up, and so many more. And so I'm going to stop here and take your questions.
Thanks, Kate, so much. Okay, so for our first question, we have some people say that the growing population and worsening environmental situation on Earth will require humanity to look for other planets to move to. Is NASA considering those scenarios, or is it doing something to help address the problems on Earth and prevent worse outcomes?
Yeah, so there was a recent report that came out a couple weeks ago, an international report about climate change on Earth, and looked at how you could limit warming to different levels. And they present some information about what that might look like. In terms of NASA's role on Earth science, so again, we're observing the Earth system, we're understanding our planet. We use models to provide windows into how climate on Earth might evolve. And so we can take those models and look at, well, what if we have more or less emissions in the future? What does that mean for climate? What does that mean for the land surface? And we use models to understand that. We also develop technologies that can help us mitigate or adapt to climate change. So I mentioned briefly sustainable aviation technologies, but the work that our aeronautics team is doing is helping us find ways to do air travel with less emissions, and that's really important. We also have work going on in other parts of NASA that create technologies that would enable us to adapt to climate change. So some of the work going on the International Space Station, like the way we grow crops on International Space Station, have implications on Earth. So we've developed LED lighting with input from NASA research that's used on the International Space Station to grow crops. It is also used in indoor agriculture facilities around the world.
That's super. And a related question that we received is, what will happen to the Earth if, based on decades of past data, if nothing is done to mitigate climate change? And also, Kate, you have this fabulously broad perspective on all of the open data that tells us what we can do. From your perspective, for all of us, what are some of the things that we can do every day independently that can contribute and mitigate climate change?
So a couple of things that you mentioned there. One was about data and getting data to people. And I think this is a really big goal of NASA and of science more broadly, is trying to make sure people have information they need when they make decisions. Some of the ways that we do that right now with NASA is in terms of climate impacts and disasters. So we have an applied science program and a disasters program that provides near real-time information to local responders and local governments before, during, and after disasters occur, so that they can help respond to that. And just as a concrete example of that, we have for something like a wildfire, we can see where fires are burning. We can see burn perimeters and burn scars. We can help provide information about emissions associated with fire and air quality concerns that are related to those emissions. We can also provide some insight into fuel for fire. So whether or not, fires, they need something to burn. And so we can give information about how dry the conditions are and whether they're conducive to fire. So that's in terms of open data. Another part of your question is what happens if we don't mitigate climate? And so one of the things the international science community does, and this is in the report that I mentioned earlier that just came out a couple of weeks ago, is they look at different scenarios of how the future might unfold depending on what happens and what choices are made on Earth. And so those include different emission scenarios. So what if emissions continue to rise? What if emissions begin to decline immediately? And they just provide information on what that world might look like and what warming we might see. And you can see anything in that report. Some of the scenarios that have immediate emissions reductions can limit warming to 2 degrees or 1.5 degrees. Other scenarios that have continued emissions rise, we might see something closer to 3 degrees or higher. And so they can provide information on that. And that, as a scientist, is what we try to do. Here is what might happen given the things you're considering. Here is information that you might want as you're making a decision. And so the last part of your question is about what people can do. And this is also something where, everyone's circumstances are different, everyone's options are different. But what science can provide is information about the options you might be choosing. So if you're considering between, doing X or doing Y, we can give you information about the emissions associated with each of those options, and also what it might mean more broadly, like what does that mean for land or water, biodiversity. And there is a lot of resources on that. It's hard to answer that in a comprehensive, general way. But what we as scientists try to do is make sure that people have what they need as they're making decisions.
That's great. Thanks, Kate. Our next question comes from Helen. She's located in the US. She says, I'm currently working on a project related to exoplanetary classifications. How does the climate change impact elements like temperature, mass, and compositions of these exoplanets?
Well, that's an interesting question. So one of the things we're hoping with James Webb is we'll be able to see atmospheres of exoplanets and in some case get a sense of temperature. And so when you're thinking about, within our own solar system and what we know from physics and chemistry is that temperature depends on both your distance from your star, so how much incoming solar radiation, but also what the atmosphere is. So higher concentrations of carbon dioxide mean warmer worlds because carbon dioxide traps heat. Same with the other greenhouse gases. And so if we have a sense of the atmosphere and the distance from the star, then we can get a sense of the temperature on the planetary body. And again, physics is physics, chemistry is chemistry. And so what we understand about Earth and what we can represent there would apply to other planets. What would be different is what is the surface of that, what is the atmospheric composition, what is the distance from the star. You also asked about climate change, and I think there, one of the things we're doing both Venus and Mars is trying to understand the climate change that they've undergone. But you need observations and different sorts of samples to try to get at that.
Okay, thank you. All right, we have a question from Sumit in Bangladesh. And Sumit asks if there are any NASA programs that support overseas space technology projects for teams who do not have a space agency in their country.
So we have a lot of partnerships internationally, and I'll just touch on a few. So some of them, first of all, with countries that have space agencies, a lot of our missions are partnered missions. So I mentioned a mission in Earth Sciences coming up this fall called SWAT. That's a partnership with the French Space Agency with contributions from the Canadian and UK Space Agency. So we work with other space agencies, and the contributions in each of those missions differ. So sometimes it's, launch, sometimes it's, particular technologies or sensors, and it just depends on the mission and the partner. We also do have programs to work with countries to help use satellite-based resources. So we have a program in Earth Sciences called SERVIR, where it's in partnership with USAID. And with that, we actually work with locals in different countries around the world to help them use satellite-based information to make informed decisions. And then we also have our space technology team. There's a bunch of spin-offs. So a lot of the technologies we develop, we get them out into the world and transfer that technology to partners all around the world so other people can use what we've developed.
That's awesome. And maybe circling back to the answer that you provided to an earlier question, we got a follow-up question here from Angel in California. And Angel says, you mentioned that there are already robots on Mars and that there will be robots working on the moon. Can you tell us about how these robots work, how they can help scientists, and what challenges they are currently facing? And Angel adds that the reason she's asking this question is because there are some teenagers on their team who have a lot of work and interest in working with robotics, and they aspire to help create even better robots to work on different planets.
Yeah, so for on Mars, we've had several rovers on Mars through, over the years. So currently the ones I was mentioning today was Perseverance, which is a rover that arrived on Mars about a year ago or a little over a year ago. And then the other thing we have on Mars right now is Ingenuity, which is a helicopter. And Ingenuity, we were trying to test, powered flight on another planet. Like, can you do that? And it's turned out that, Ingenuity has had, I think it's over 24 flights now. And it's actually, the two of them can now work together to explore the Martian surface. So Ingenuity can kind of look above and see what's going on, and then Perseverance can travel along. And what Perseverance is doing is it's both taking pictures so we can see, it's also taking samples, and those samples will be returned to Earth later. And I think, when we're thinking about that, other planetary bodies, doing that sort of image taking, and it's closer than what you would get from an orbiter, right? Perseverance is on the ground. We're getting to see those samples up close and those images up close, and it can take samples, and so we can look at the composition of the ground there.
Great. Now we have a question from Valeria on the Go team. And Valeria says, okay, so there's no silver bullet solution. We understand that. But does NASA have an understanding of what solutions are most impactful in keeping us within 1.5 degrees of warming, such as maybe clean energy ramp up versus regenerative agriculture or changes in consumption and that kind of thing?
So this is the question you asked about NASA, but it's actually a broader science community question. So, NASA has a portion of this where we're doing research in aeronautics and in space operations that are related to specific technologies. But the broader picture of all of the technologies available to mitigate is something that's done by the broader international community. And I'll just mention, so the Intergovernmental Panel on Climate Change, this is a UN level body that's charged with assessing all of the scientific literature about climate and producing reports that assess and summarize all of that science. And they produced a report about 2 weeks ago that summarizes all of what we know about mitigating climate, including, different warming levels, different technologies, and different solutions. And their report is available. If you Google IPCC, you can see it. But one of the things that they go through there gets at the answer to your question. So they look at all of the mitigation options that we're aware of now and give an assessment of, what is the potential for each of them to contribute to mitigation at different costs? What are the implications of using those technologies for other aspects of sustainability? Thinking about like the Sustainable Development Goals, and do they enhance sustainability, or are there potential conflicts that need to be thought about going forward? And so it goes through a whole long list of technologies and solutions there, more than I could go through in this brief time.
Awesome. Okay, so now we have a little bit of a pop culture question for you, Kate.
Okay.
Have you seen the movie Don't Look Up? And the reason to ask that question is that learning about a planetary defense mission reminded the person asking this question of that movie. And the more specific question is that in that movie, it's about, an interpretation of the world's reaction to climate change. And at one point in the movie, the scientist character screams, "We're all going to die," on national television. And so as NASA's chief scientist and climate advisor, your message would probably be a little bit different, but we're interested to learn, what would your message be, and how would you make sure that you were getting people's attention?
Yeah, so just first of all, I have seen the movie, and one of the things that I related to the most in that movie is actually one of the early scenes where the first time they're interviewed on television, and you can see that sort of, you can tell that they're nervous and scared, and the default was to turn to very technical language. And I've definitely experienced that as a scientist. When you get a little uncomfortable, a little nervous, my default is to switch into very technical, spit out numbers and very precise terms, which perhaps isn't the easiest way to communicate. But when you're nervous, that's what you do. You fall back into what you know. And so I just want to relate that that's what I related to the most. I also thought in that movie, they mentioned the Planetary Defense Coordination Office. And that is the real office in NASA that I mentioned that's doing the DART mission, which is really exciting. Just in terms of your specific question, I think what we know from science, we know that climate change presents challenges. We're seeing those. We're seeing more extreme events. We know that those will increase with warming. We also understand the Earth a lot better than we did a long time ago, and we have a lot of information about potential options to mitigate or adapt to climate change. So we have a lot of information. And as a scientist, I like to focus on the information and trying to make sure that people that need to make decisions have access to that information.
Thanks, Kate. And the last question that we have here is again from Helen. And she says, our team created an aeroponic system that reduces resources and carbon emissions in the atmosphere. Does NASA see these modern agricultural methods in their solutions to reduce carbon emissions and stop climate change?
Okay, so two parts of that. One is just, so first of all, NASA is a science organization. So we do scientific research and provide that to people that are making decisions. And then secondly, more specifically about agriculture, we have a long-standing, we do work with the US Department of Agriculture. We do research on growing crops in space. And a lot of what we're doing is trying to think about when you're on the International Space Station, you have to bring everything with you. And that makes you think about sustainability and use of resources. And so a lot of the research we've done growing crops on space station have implications for Earth. So I mentioned earlier research into LED lighting that's used in indoor ag facilities. There's also a fertilizer formulated with input from NASA researchers that directs nutrients to the plant roots at the rate that they need them. And on Earth, that means less runoff into rivers and lakes. And so there's a lot that we're doing there to think about that. But our goal is to provide research and information that's relevant to people. And in support of the activities that we're doing.